That's the way to do it. Yeah. At FOSDEM for Lightning talks, they have a really annoying alarm clock that goes off every like 10 minutes or 15 minutes or whatever the slot is. Yeah. Oh, speaking of time, there are no clocks in this room, so cool. No, I was looking more for tracking time while I was speaking, but it's fine. What? No, so these used to, I've given a version of this talk before, and I had it titled Building Community with CentOS Stream. But this is more of like a historical bent, so that's why the title is different. Tech comedian, that's, yeah. There's a half cup of mocha at the booth if you want. No, that is not the solution. Yeah, there is coffee outside though. It's actually drinkable, so. Yeah, that's. You need to try different kinds of stimulants. All right, 2 minutes. No, there's no rush. Oh, so I'd rather make life easier for whoever is going to cut this afterwards. No. Should have grabbed that less squeaky bottle. Alrighty, I think we're at time, so we can probably get started. Cool. Morning, everyone. My name is Davide. I'm a production engineer at Meta, and we'll be talking about building the future with CentOS Stream. Here's the agenda for today. We'll start with a quick historical introduction of how we've been using CentOS at Meta and how that changed throughout the years. We'll talk specifically about contributing upstream and the work we've been doing in this space. We'll then deep dive into the hyperscale SIG, which is one of the most recent efforts we had in terms of contributing upstream within the CentOS project. And we'll close with a few words on how you too can get involved. So let's get started. As I said, I'm a production engineer. I work on the Linux team right now, which is responsible for all the components of the Linux ecosystem that run in production at Facebook. So the Linux distribution, but also systemd and components of the user space and the kernel and all of that. Before that, I was on the operating systems team, which took care of the deployment and maintenance of the distribution in production and the platform that all the other services at Facebook were running on. I'm going to say Facebook and Meta interchangeably because I'm still not used to the name, sorry. So Meta has a lot of machines. We have millions of servers spread across the globe in several data centers. All of these are physical servers, to be clear. We don't really use VMs for production. All of these servers run CentOS, all of these servers run Linux, and I've been running CentOS since the beginning, or since as far as I've been at the company. I started in 2012. So before we talk about how we use CentOS, I want to spend a few moments talking about why we use CentOS. CentOS has a lot of very desirable properties in a Linux distribution for a production environment that you may want to run. First of all, CentOS gives you stable releases, and stable releases are excellent checkpoints because you can use them as synchronization points in time whenever you want to apply other changes. And I will talk about that a bit more in a minute. Critically, CentOS gives you binary compatibility, and that is a feature that is not quite as common in Linux distributions these days, but it is extremely valuable when you're doing deployments at scale. Binary compatibility means that at any given point in time, I can update packages on a production system, and whatever is running on the machine will keep running because the updates within a given release of the distribution, so within, like, say, CentOS 8 or CentOS 7, they have ABI and API compatibility. So I can update libraries under the hood, and while a package is running, and the package will keep running. And like this works like 98% of the time, because sometimes people screw up, but for the vast majority of time it works. And it means we can effectively apply security updates and any kinds of updates in production on the fleet in a mostly unattended fashion and expect them to just work. Speaking of updates, of course, we have security updates, which are valuable because we like security. Because CentOS is part of the Red Hat ecosystem, which has been around for a while in this space, it has a lot of very mature and well-understood tooling. At this point, we understand very well how to work with things like RPM, with the packaging stack, with all the tooling that are specific to this infrastructure, which is also very easy to build on top of it. Also, because it's part of this family, can also leverage the extended Red Hat family. So we can leverage content from EPEL, which are the extra packages for enterprise Linux, and we can leverage the fact that CentOS is built from Fedora and make changes into Fedora and see them then trickle down to CentOS. And we will talk about this specifically in a bit more. So over the years at Facebook and at any other environment, really, if you maintain a complex production infrastructure for a while, you will notice that you run like 80–90% of stuff as it comes from upstream, but then there's some things that you need to make changes of, be it because you need to update a package internally, or you have internal packages you have to add, or you have missing dependencies and all of that. So the way we handled that up to a few years ago was that we would keep internal backports of packages that we cared about that were tracking upstream more closely. So we have packages like systemd, where we do a lot of development upstream, and we would want to follow the upstream development closely instead of being pinned to the stable releases that CentOS provided us. So we take these backports from Fedora Rawhide, which is the development version of Fedora, and we maintain those internally. And then later we realized that there wasn't really much of a point of keeping these internal only, so we put this on a GitHub repo, which was that repo. And we wrote this in a way that we gated the Facebook-specific changes under a macro, so that if you too wanted to build these packages, you could use them and run them in your infrastructure, and you wouldn't get like our NTP servers and stuff. We call this internally FTL, a fast thin layer, and this gave us the ability to effectively have a distribution that was stable, but it was also moving as quickly as we wanted. And we mostly applied this approach to lower level packaging in the distribution. So as I mentioned, things like systemd, things like the user space plumbing. The other thing that we did is that we do not run the stock CentOS kernel. We never really did. We've always ran our own kernel build, primarily because we have a lot of kernel developers who do a lot of kernel development in-house at Meta, and it is a lot easier to just run the upstream kernel because that's where the development is going to happen anyway. That's where the changes are going to be merged, rather than running a vendor kernel that has a lot of backports that then you have to maintain and ends up being a very different beast. We also make a number of policy changes on the kernel side where, compared to the distribution, we run, for example, with Syrup2 by default. We use ButterFS extensively in Meta, and ButterFS has been the root file system for the entire fleet as of CentOS 8. Yeah, it was with CentOS 8 that we flipped it. But we've been using it even before when we were at the fleet mostly on Cent 7. So this is an example of what we call a policy deviation. So it's something that we consciously make a choice to put something in production that is different from what the distribution itself is doing. Other examples are for IP tables. For a variety of reasons, we don't use NF tables in production in Meta. We want to still use the legacy IP tables backend. So we rebuild the IP tables packages with that backend enabled. On the networking side, upstream CentOS has been using Network Manager for a long time. We don't really use Network Manager in production. Historically, we've been using network scripts since Cent 5 and earlier, and that's what we kept running until effectively today. Right now, we're in the process of moving from network scripts to systemd networkd. That is what I expect we will deploy fleet-wide with CentOS 9, and we're in the process of refactoring it and rolling it out to a portion of the CentOS 8 fleet as well. Now let's talk about upgrade. As I mentioned, I've been at Meta since 2012. When I joined in 2012, we were running CentOS Linux 5. We didn't really have a process at the time for doing OS upgrades, so we kind of stumbled through it and managed to eventually update the fleet to CentOS Linux 8, and that took a while. CentOS Linux 6, and that took a while. When we did 6 to 7, that was a big transition, because 6 to 7, if you remember, was the one where systemd was introduced. And that meant having to convert all of the services we had internally, where at the time we had like 5 or 6 different init supervision systems for services, and having those come. Yes, Neil. I have another talk on that if you want, but it's not this talk. And it was converting all of these onto systemd because it was a great opportunity to get rid of a lot of technical debt and craft and just use a unified system. That was also the first time when we started actually actively engaging, I would say, with upstream and trying to work with folks. We worked with folks on Anaconda, for example. At the time, we were using Anaconda as a system installer. We started engaging directly with the systemd project and contributed a number of changes that were informed by our production deployment. More recently, we've been migrating the fleet from CentOS 7 to CentOS Linux 7 to CentOS Stream 8. And right now, we're in the process of starting the 8 to 9 migration. We just finished qualifying CentOS Stream 9 in the past few months, and we've kickstarted the mass migration earlier this month. I expect that will take the better part of this year and the next. These things usually always take a while. The reason these things usually take a while is because when we do major OS upgrades, we do full reprovisioning of the system. So we wipe the machine, and we reimage it from scratch as if it were a new machine. There's a few reasons why we do this. So first of all, technically, in-place upgrades aren't supported for CentOS. There are ways to do in-place upgrades with CentOS, and if you actually try it, it will mostly work in the vast majority of cases. There's also tools that you can use to make this work better. There's the Elevate tool that the Alma Linux folks have. There's the Leap toolset that Red Hat maintains. However, we don't really want to do in-place upgrades because when you do an in-place upgrades, it means you're carrying back all of the stuff you had previously on the system. It is a rare opportunity where you can have a clean slate and you can choose to actively deprecate things and switch to new things at the same time. So we generally treat the OS upgrades as synchronization points where we can also couple a number of other things with the upgrade itself. So usually we will switch the default kernel to a more modern kernel that has features we care about. And because updating the kernel implies a reboot, well, you're rebooting anyway already if you're reimaging the machine, so you might as well do that. We've used this when we switched the root file system to ButterFS, because you were going to reimage the machines anyway. We've used this in the past to also deprecate various things, various internal services, because at the time it was a good opportunity. And because this leverages the general maintenance windows we have, it can leverage all the existing automation. The way we do this in practice is that service owners Oh, and to be clear, at Meta, the general understanding is that if you run services in production, you own the machines that you're running the services on production, and you're generally responsible for doing these migrations yourself. We will provide you the tooling, and we will give you deadlines, but the actual mechanics of the migration are going to be up to you. What people have been doing in the past, this was a fairly manual process, but as of half of Cent 7 and beginning of Cent 8, we had really good tooling for doing this in an automated fashion. So people can effectively say, I can lose these many machines at this rate with these physical constraints, fire, and then they'll start, and the automation starts churning through machines, takes them offline, reprovisions them, puts them back online, checks that they're healthy, puts them back in production, and so on. So it's a fairly hands-off approach, as long as there aren't any regression or any issues, of course. And we've been fine-tuning this tooling. This tooling is unfortunately very tightly coupled with our infrastructure, but you could build something like that out of open source tooling. There's nothing particularly earth-shattering in it. Now, we don't do reprovisioning for everything. We only do that for major OS upgrades. For minor OS upgrades, we just do incremental updates by effectively running the NF upgrade like you would expect. We snapshot the YAM repositories, so we always have a stable point in time that we can reference. We do snapshots every 2 weeks of all the repositories upstream. We started doing this process before composes of the distributions were a public thing. Nowadays, if you were to implement this from scratch, you would probably just want to use the CentOS composes that they publish. And if you're not familiar, a compose is basically the distribution is put together and packed in a compose, and it's an installable set of the entire distribution. And they publish these between every few days and every few weeks, depending on the development cycle upstream. So that's a good synchronization point if you're building something like that. In our case, we just take snapshots of the live repos every 2 weeks, then we roll them out of the fleet across 2 weeks. We do the actual rollout using Chef, which is our configuration management system. So Chef has some logic in the codebook that manages the NF and YAM. It has logic to figure out, okay, I am on version X, we're moving to version X plus 1, update the repo definition, run the DNF update, check that it's fine. Of course, we have ways to monitor that this is going well. We have ways to stop it. We generally start the rollout on a very small portion of the fleet and canary it up. But because of that binary compatibility guarantee I mentioned before, this is more or less a hands-off approach. Generally, whenever we do this, we will spend a day or so at the beginning to check for conflicts, check for issues. Oftentimes, the issue you end up is because of some internal packages that has messed up RPM dependencies that we have to fix. The upstream stuff usually works just fine. And then you apply it, and you roll it on, and you move on. Now we should talk about containers as well. Although everything I said so far has been about bare metal. The reality is that these days a lot of production workloads don't run on the bare metal directly. They run on the container platform, which itself runs on bare metal. The container platforms at Meta is called Tupperware. It's an internally developed platform. The development started long before containers were a thing, or at least a widely used thing. But they use all of the traditional container technologies you might expect. So C groups, namespaces. We increasingly using more and more features from systemd for the container management itself. And in fact, the container agent that we run on the host is primarily based on systemd nowadays. While Tupperware itself is not open source, a lot of the components are slowly being rebuilt on top of open source tools. And as part of this process, we're improving the corresponding tools. The containers themselves also run CentOS. In fact, they run the same CentOS that we use for the bare metal hosts. We build the container images from the same repositories we use to build the production systems. We have an internal tool for building container images called Antler, but it's like about the same as any other container image build tool that you might expect. The good thing and bad thing about containers is that because they're decoupled from the host, the update cycle doesn't have to be in sync with the host. So you often end up with having, say, CentOS 7 containers running on CentOS 8 hosts and vice versa. This is good and bad in that it makes updates easier because you can carry on older living containers. It's also bad because you oftentimes end up with stragglers, and sometimes it does matter. The difference does matter if you're, for example, transferring data back and forth. And in the case of containers, obviously, we don't do in-place updates because they're containers. It's a lot easier to just tear it down and bring it back up with a new image. OK, so what I talked about so far is roughly what we had been doing up to like 2016, 2017. Over the years, this approach worked, but we definitely found that there were kinks, there were issues. It was tricky at times to do this nicely. For FTL specifically, because we were maintaining these many backports internally, Every time you backport something and you maintain it yourself, you're effectively forking it. If you fork something, you have to maintain it forever, or at least throughout the lifetime. And because these are forks, you don't really have a good solution to upstreaming the changes you're making. Well, you can send PRs, of course, but it wasn't really clear. And what we would end up doing is that things would diverge quite a bit, especially for leaf packages that people may not necessarily follow super closely. Oftentimes what you see is that someone backports some random library because they need it for their tool, but they don't actually care about the library. So they'll just backport it once, and then there's 25 CVEs on it. And I was like, cool, now we need to fix that. Also, we were putting these on GitHub, but like there were just a bunch of spec files on GitHub. I know a few people were using especially the systemd backport, but they weren't super usable. And at the same time, as I mentioned, whenever things were fixed upstream, we would have to manually integrate those. And we would also have to manually integrate whenever the distro would update or pin our version so they wouldn't get shadowed. Same thing on the policy side. Whenever we made that decision to change something, we then had to deal with the consequences. And the main issue here is that whenever you deviate strongly from something the distribution is making, you run to the risk of not being able to effectively report bugs in a useful way, because the bugs you might end up encountering might be specific to your setup, and they might not apply to the distribution. So you end up having to double repro everything. And we also didn't really have a feedback loop on whether the choices we were making were useful or were things that others could benefit from. So now let's talk about how we can do better, and how we can do better by engaging more closely with upstream. I don't think I need to explain to this crowd the benefits of working with upstream, but I'll do it anyway for the benefit of the wider audience. The main thing we've discovered over the years, well, I don't think this is particularly a discovery, but the thing that I think is important to realize is that whenever you're working with projects that have a well-established and wide community, you are not going to be the one that is doing the impactful work most of the time. You're not going to be the one that is setting the direction. The community is where the work is going to happen. It's easy oftentimes, especially if you come from a large company, to think of everything you're doing as awesome and everything you're doing as the cutting edge. But the reality is that for a lot of the project, the cutting edge is what is happening outside. And if you want to be a part of that, you have to work with the people that are doing this on their ground, work with the project and make things better. Also, if you think about something like a Linux distribution, there's going to be a subset of it that you really care about, that you want to follow very closely. But there's also going to be a lot of things that you might tangentially use, but that you really don't want to maintain yourself. You don't have the expertise, you don't care. Think about, for example, if you run parts of LibreOffice for doing some production workload. Do you really want to maintain that in-house? Unless you're an expert of it and that's part of your core business. The benefit of being able to do this work upstream is that you can leverage what the community is doing. You don't have to do everything yourself, and whenever you fix something, others can benefit from it, and vice versa. At the same time, whenever you write something new, and if you make an effort to open source it at the beginning, then everybody else can contribute and give you feedback. Over the years, we found that by far the best way to do this is by just showing up to the community. If you show up to the community where people are doing actual work and engage with them as a peer, go there, solve real problems, real engineering problems. That's how you generally do work in this space. That's how you do space. That's how you become a real member of the community. That's how you can build trust with the community and gain a better understanding of what's going on. So let's talk about specifically CentOS for now. And to talk about CentOS, we need to take a bit of a history detour and look into the sausage-making machine of how CentOS was created over the years. So there's various players to these games. There's CentOS, there's Fedora, and there's Red Hat Enterprise Linux. And to be clear, I don't work at Red Hat. I've never worked at Red Hat. This is my personal understanding of how this is. So Fedora is the community distribution that is maintained by Red Hat that tends to be close to the cutting edge. It's what you might be running on your laptop right now. Red Hat Enterprise Linux is the product that Red Hat, the company, sells, which is an enterprise Linux distribution. And CentOS historically was a rebuild of Red Hat Enterprise Linux from sources. So the development process roughly went like this. They would take the version of Fedora at the time, which in the case of Central Linux 7 was Fedora 19. That was a while ago. Internally, at the beginning of the development cycle for RHEL, they would take Fedora 19 and snapshot it. And this would get snapshotted into an internal staging distribution that Red Hat would maintain, kind of like a primordial soup that they would use to slowly stabilize the distro and turn it into a commercial product. When this was ready, they would release Red Hat Enterprise Linux, and together with it, they would release the sources. Then a different group would take the sources, rebuild them from scratch without using any of the existing infrastructure and release CentOS Linux as the product there. So if you're us and you're running CentOS Linux in production, you would then take CentOS Linux and deploy it. Now let's say you're running CentOS Linux 7 in production and you find a bug and you really want to fix it. You fix it internally, but you would like the fix to go upstream so you don't have to keep maintaining it forever. What can you do about it? So your options are kind of limited in this world. You can't really contribute to CentOS because CentOS is just a rebuild of RHEL. There's no, the only real meat in there is the build and the build process that's rebuild the distribution. There's not really anything else. So you can't make any changes there. You can't really contribute to RHEL. For starters, RHEL is a product. Even if you are a customer of Red Hat, they didn't really have a way to send PRs. There wasn't a development process. There wasn't a Git forge or anything. You could file issues on Bugzilla, and maybe they will look at it, maybe not. Maybe they will take the patches, but your options were kind of limited there. And even if you did get your patch included, it would be included into the next minor release, which might not be coming for a while. You obviously can't do anything about the staging distribution because it's internal to Red Hat. The one thing you could contribute is Fedora. And while you could absolutely do that, if you manage to get your changes landed in Fedora, they would only impact the next major release of RHEL and CentOS, which would be years off. So you were kind of stuck. You effectively had to maintain a lot of stuff internally. With 8, things changed a little bit. With 8, the process was similar. They started from Fedora 28. They branched it into an internal distribution, which I didn't put in the slides because it didn't fit. But then when they released Red Hat Enterprise Linux 8, they also released something new called CentOS Stream 8. And the idea is that CentOS Stream 8 is a continuously delivered distribution that is developed in the open. And that's where changes land first. And then changes from there will land into the next minor release of RHEL. So it is effectively the distribution that Red Hat used to have internally for developing the next minor release of RHEL before it went out. If you're running CentOS of RHEL, you probably remember that you had like a base repository and then you had an updates repository that was getting a trickle of updates. That's where those updates would come from, effectively. With 8, these updates just show up in CentOS Stream after they went past the Cicd pipeline and everything. But the new thing here is that all of the sources for Stream were easily accessible in one place, and there was a contribution process. So you could actually send PRs, you could send bug reports, you could get these merged. You could apply changes to the distribution, and they will land in the next compose. So if you found a bug in like some fringe package, I don't know, nmap or something, you could send the fix upstream, and if the fix was deemed acceptable, because obviously this is like any other project, they can choose to take or not take your contributions. But if the fix was deemed acceptable, it would get merged, and then you could just deploy it. And this massively reduces the burden of having to maintain things internally because you don't have to, you can just get them up. With 9, which is where we are now, things have changed even more. So with 9 we started from Fedora 34, which is not that long ago, actually. And in addition to releasing CentOS Stream 9, there is also a new distribution in the middle, which is called Fedora Eln. And Fedora Eln is effectively the staging distribution that I was mentioning earlier, but public. Not only but public, but continuously updated at any point in time. So the idea with Eln is what if we took the development version of Fedora today and made RHEL out of it, with it every day. And it is something that exists that you can install today, and that gives you a window into effectively what the next major version will be. Then, of course, you have CentOS Stream, and the other change with 9 is that they dropped the CentOS Linux rebuild. So the only deliverable that comes out of the CentOS project itself is CentOS Stream nowadays. So to recap, there are many avenues that you can use to contribute in this ecosystem if you want to be involved. You can work at the layer of Fedora. Fedora is what influences what goes into the next CentOS Stream major release. It is a great place if there are new technologies that you would like to see adopted, if there are things that you are developing on, especially if there are things that are relevant to the whole ecosystem, it is a great place to do this work. It is also a great place to maintain packages. If your company or your environment has open source software that they care about, making sure that the software is packaged and maintained in Fedora is a great way to gain user adoption. One thing I wanted to stress in particular is the change proposal process, because I think it's a very good process for managing change at scale into the distribution. And in the case of Fedora, the way this works is that whenever anyone wants to change something notable in the distribution, they can put together a proposal. They have to do the actual work, obviously. But then if the proposal is approved, the changes are implemented in the distribution and become available to everyone in the next release. And over the year, we've leveraged this process quite a bit, and there are several changes that we landed in Fedora. To be clear, this isn't just work that Meta did. All of these things had major contributions from the community, both from other companies and from community partners that helped us. For Fedora 33, we landed Btrfs support by default. And as of Fedora 33, Fedora ships with Btrfs by default as the root file system. With 34, we ship Btrfs with the standard compression by default, which made it more efficient on solid-state drives and other environments. With Fedora 34, we also shipped systemd umd by default. Systemd umd is a user space out-of-memory implementation that it leverages some new kernel features that can more or less predict the future and figure out when your system is about to go out of memory, but before it actually goes out of memory, so that the applications can react before the killer, the kernel killer is unleashed. This is something that was developed at Meta within systemd, upstream to systemd, and then deployed to Fedora. With 35, we switched Btrfs by default also for the Fedora Cloud images. With 36, we moved the RPM database to user, which helps for some snapshotting use cases. For 37 right now, we have a few changes in the works and for future releases. I'm not going to read all of the slides. If you're interested, you're welcome to ask me questions, and I'm happy to go in details. If any of this sounds interesting, you're also welcome to help out, obviously. We can always use more help. And if you too would like to make changes in Fedora, this is how you too can do it. Now let's talk about EPEL. I mentioned EPEL briefly at the beginning. So Fedora releases packages for its own distribution, which is Fedora. But a lot of these packages are useful also in other environments. With EPEL, a subset of Fedora is rebuilt and targeted for enterprise Linux. So the packages can be used on RHEL and on CentOS Stream. We use this a lot. Because the set of the base packages of CentOS is pretty small. There's a ton of other packages you may want to use in production. You really don't want to maintain them internally, so being able to leverage the packaging that is done in Fedora is incredibly useful. In more recent years, there's been an effort to try to make this process more streamlined. Historically, whether a package was branched or not for EPEL was really up to the maintainer of the package, which was generally a single individual human that may or may not care about it. And these days, we try to set up a process so that packages can have more of a collective maintenance if needed, so we can share the burden. A lot of the time, packaging something for EPEL isn't terribly challenging, but it's also not terribly interesting. You're basically like merging all the changes from the other branch, doing the build, checking that the build works, cool. That there's rarely any challenging work to do there. So it makes sense to have more of a streamlined approach to these. We also did a lot of work on tooling. One of my colleagues, Michelle, is working on a tool to automate the process of branching packages so that it will be easier to add them in the future. And we set up a special interest group to generally manage the collective maintenance of EPEL more easily. I mentioned ELN earlier as well. ELN, as we've said, is a continuous rebuild of Fedora Rawhide, but using the CentOS macros and the CentOS toolchain. So the end result that you get out of it is effectively CentOS, but if it were built against today's sources of Fedora. This gives you a window in what the next CentOS version could be. So if you look at ELN today, ELN is what will CentOS 10 build be in a year and change when CentOS 10 will be branched and come out. There's a special interest group for ELN as well that we've been engaged. Most of the work there has been around making ELN easier to consume. ELN produces installer images, it produces a set of repos. And also how we could extend this to more than just the basic distribution. One idea that we had early on was that we could use this to also make life easier for EPEL, because if you're testing packages for the new version of Stream, you might as well test the set of packages that are also going to be branched for EPEL while you're at it. So this is covered by something called ELN Extras, which is effectively a set of additional packages that wouldn't be part of the distribution itself, but are still tested and composed together with it. At Meta, we are using this in a variety of ways. For starters, there's a number of open source projects we maintain that we want to make sure keep working in Fedora and in CentOS and stay packaged properly. We do this by having a Cicd pipelines in these projects upstream that leverage Packet, and Packet delivers us RPM builds for various shrouds, and one of these shroud environments is Fedora Eln. And not only delivers us this build, but delivers us nicely formatted repos. So if you want to test today's build of, say, the below resource control system, resource control daemon with Fedora Eln or whatever, you can just get the packages from there. This is done through a system called Packet. The other thing we do is that for packages that are, as I mentioned before, in EPEL that we want to track, we have a workload in content resolution so that they're branched for ELN extras. These are either packages we maintain or packages that somebody else maintains, but that we want to track closely. Internally, we're also in the early stages of establishing a Cicd pipeline using ELN. The idea is that whenever we do a new CentOS major release qualification, there's a period of several months that we have to take to do qualification. And it'd be real nice if we could spread that instead across. And if we had a way to deploy ELN to the fleet and run a production workload on it throughout its life, we could spot issues very early on and either work on them internally if they turn out to be issues on our side, or work with upstream to see if we can maybe make things easier and better for everyone. Moving on to CentOS. CentOS Stream, as I said, is a continuously delivered distribution that tracks the next minor release of RHEL. So if right now we're at RHEL 8.3, 4, I don't actually know, this would track RHEL 8.5 or X+1. You can file bugs for CentOS Stream that way. The reason I put that on the slides is because I find it entirely non-obvious, because you have to actually file the bugs for RHEL, but putting CentOS Stream as the version. All the sources for CentOS Stream are on git.centos.org. And by sources here, I mean all of the package specs. The way the CentOS community is governed is via special interest groups. And SIGs are really the building blocks of the community. And that's where all of the interesting work and development work happens. And I will talk about SIGs a bit more in a second. For Stream 9, it's more or less the same. As you can see, the slides are pretty similar, except the sources nowadays have moved to GitLab. So if you go on gitlab.com, write a CentOS Stream, and you can use the GitLab MR workflow, which you might find a little bit easier than the previous one. The builds are on Koji in the same way. There's a different Koji for reasons for 9, but it doesn't really make a practical difference. And that's the link where you can find the daily composes if you would like to try them out. We use this process. I mentioned before that there's now a process for doing contributions to Stream, and we actually leverage this quite a bit for the 9 devel cycle. Because of this, we were able to land a variety of changes into CentOS Stream 9 long before RHEL 9 actually came out. So these were all changes that were landed in CentOS Stream 9 between the time it branched and the time RHEL 9 was out. This was great, frankly, because these are all things that we would have had otherwise to do ourselves. That maybe would have taken months to years to get into the distribution proper, and this way they were just there. And we plan to continue doing this in the future. To be clear, again, this is not just work that we at Meta did. This was the result of cooperation between us and members from the community like Neil, who is smiling on the second row, that helped us a lot through this process. Now let's talk about SIGs, and specifically about HyperScale. The HyperScale SIG is a special interest group that we founded in January of last year. The idea behind HyperScale is to have a place for companies and engineers that want to work on large-scale infrastructure to work together. It focuses entirely on CentOS Stream, and in general, what we want to do is to have a place where all of these companies that do tooling development and deployments in-house, they might end up kind of reinventing the wheel themselves all the time. We want them to cooperate on this together in a place that is in the open. So bringing all this in-house development out so that folks can work. These has folks from Meta, from Twitter, from Datto, from a variety of other companies. Intel as well now. But you don't have to be in a company or in a company of any kind or in a large company to be a part of this. You can also just be interested. And while these nominally targets large-scale deployments, the reality is that a lot of the work we're doing here is hopefully also useful to smaller-scale deployments. There's a few links there on the splash page of the SIG and our user documentation. We hang out on IRC, on Libera, and the room is bridged on Matrix. Most of us are in US Pacific time, but there's usually someone around all the time, so you're welcome to join and ask questions if you would like. Primarily, we do a few things here, and I'm gonna try to go over quickly the main things we have. The main deliverable of the SIG right now is what we call faster moving package backports. So I mentioned earlier this FTL thing we used to do internally at Meta. This is effectively the same, but done properly and done in the open in a way that other folks can contribute to. So we deliver updated backports of distribution packages, either with new features enabled or that follow upstream more closely. And the idea is that if you're running CentOS Stream 8 or CentOS Stream 9 and you would like a more updated version of a package, you can install the version that we provide in hyperscale, and the distribution will keep working just the same as before, just better. These target stable and production use, and these are the same package that we are running at Meta in production. If you have a CentOS system right now, you can get this by doing DNF install CentOS release hyperscale, which will enable our repos. And then if you do DNF update, this will update all of your packages to ours. If you don't want that to happen, you can use version lock or other solutions to pick and choose what you want. There's a lot of packaging in here. I will not read through the list, but you can pull up the CBS tag to see it. CBS is the community build system, is where builds for packages that special interest groups work on happen. Most of these is what we call like low-level system user space or Linux user space. So things like util Linux and Raycat, packages that allow you to do either hardware enablement or enablement for new features or support for newer kernels and things like that. I want to talk specifically about systemd because I think it's a great example. We've been maintaining a systemd backport for several years at this point that was tracking the latest production stable release of systemd. This is what we've been running in production at Facebook or at Meta for years, and it is based, as I mentioned before, on the Fedora Eln packaging. You can see this on Git.CentOS. You can see the spec files for these. We maintain these in its own Git repo as well on Pagure, so it's easier to track patches and to see what changes have been made. But mostly these tend to be like verbatim imports of upstream releases with the occasional bug fix on. We also have a Cicd pipeline where every day we take the latest Git master of systemd and we build it against our packaging and publish it. This makes it really easy to spot regressions in the build system. It also makes it easy if you want to test a one-off feature that was just merged into systemd and see how that's working out for you. You can just grab this package and install them. This uses the CentOS OpenShift CI environment. One of the things that CentOS provides special interest groups is access to an OpenShift environment where you can run effectively arbitrary container jobs. This is great, and it's made our life very much easier than having to re-implement this in-house before. The other set of changes that we do, as I mentioned, is what we call policy changes and configuration alternatives. And the idea here is that we will release packages that have different defaults, but should still be usable and should still not apply negative changes to the distribution. So the traditional example here is iptables, where we ship a modified iptables package that also has the legacy backend enabled. So if you don't want to use nftables, you can use that. Now, everything I mentioned so far are things you would want to run in production, and you should be able to run on your production machines without any issues. The other set of things we work on are experimental changes, things you may want to run on your production machines, but you don't necessarily want to deploy everywhere. A lot of the time when you're doing development of distro-wide features, it is really useful to be able to test those and deploy those in production. But it's often not just a matter of building one package. It tends to be a set of interconnected changes. So a good example here is the work we've been doing for a while on DNF and RPM copy on write. That's its own talk altogether, but the short version of this is that it's a set of changes to the RPM packaging stack that allows it to leverage the copy on write features that modern file systems like Btrfs provide to make package installation a lot more efficient. This requires changes to RPM, DNF, the entirety of the stack. This is something we run in production at Facebook now, but it's something you may not want to run on your environment until it's stabilized a little bit more. It's also not in Fedora yet. We have been working on a change proposal to get it in Fedora. But if you want to try this, it is also available in hyperscale. You can install our experimental repo, and that will give you access to this set of packages that you can deploy in production and use, or in your test environment if you prefer. In the same repo, you will also find our kernel. For several months now, we have been building 5.14-based kernels as part of hyperscale. We use 5.14 because 5.14 is the kernel that's shipped in CentOS Stream 9, so we can have the same version on both 8 and 9. This is effectively the same kernel that shipped in 9, but it has a number of extra features enabled, notably Btrfs. So you can use CentOS with Btrfs and even install a system from scratch on a Btrfs file system. To be clear, this is not the kernel we run in production at Meta. It is a kernel that is based on some of these things. Longer term, I would like to see kind of a closer, bringing this closer to the kernel we run internally and vice versa, but we're not quite there yet. In addition to the kernel, we also maintain what we call the kernel user space, so packages that are tightly coupled with the kernel you may want to update at the same time. So things like Btrfs browse and ComSize, which are Btrfs-specific tools, isTool, which is often something you want to update for hardware support, and Kpatch, which is used for the kernel life patching environment. We have a lot of other things we're doing in hyperscale, and I did not put a full list here. A couple of notable things I wanted to mention is that we have container images. So if you want to play these very quickly in your container environments, you can pull the images. These are minimal container images that were built from scratch using Builda. They're not based on the official CentOS images. The reason being because the official CentOS images are based on UBI, and that carried a bunch of baggage we didn't really want to deal with here. Also, you can use the build scripts if you would like to build this on your own. There is like a 20-line bash script, so it's nothing particularly fancy. We've also started maintaining live media spins. So if you've installed CentOS recently, when you install CentOS from the DVD, boots into Anaconda, and you install Anaconda, but you don't have a live system. If you install Fedora, you get a nice live desktop and everything. The idea is to have spins, installer spins that look like the Fedora ones, where you have a live desktop, so you can try the system and play with it with all of our features baked in into enabled. So you boot into a system that has our systemd, it has support for Btrfs, it has up-to-date packages, so you can both use them if you need to, say, rescue a live system, but you can also install this since the beginning with Btrfs and all of that. Right now, this is only released for CentOS Stream 8 because we haven't updated the build system yet, but we are in the process of getting this out for 9 as well. There's many things we would like to do that we haven't started yet. Cloud images is the first one, a way to leverage transactional updates with Btrfs, better testing infrastructure so that we can have automated notifications whenever there are issues with all these packages. If any of this sounds interesting, if you would like to help, if any of this sounds fun, please reach out. We can definitely use more people. If you deploy this into your infrastructure, I would also love to hear. It's always great to hear user stories and what people are doing with the things we build. Now, as I mentioned, I promised you a few pointers on how you too can get involved. All of these communities are very easy to get into. These are very welcoming communities. It is very easy to get started, and there's a sliding scale of things you have to do. You can do to work in that and bring a benefit. You don't have to necessarily do coding work. You don't have to necessarily do packaging work. Even working on something like documentation is incredibly valuable and something that would be welcomed. The main point where the CentOS community gathers is the CentOS mailing list, which is CentOS.devel on CentOS.org. That's what you would want to subscribe if you want to follow what's going on there. Most of the mailing list is mostly for async discussions, but most of the, I would say, actual work for CentOS tends to happen in meetings. Meetings, although they're often either IRC meetings or the occasional video meeting, these are all open. Even meetings for like SIGs you are not a part of, they're all open to the public. You can join them. You're welcome to introduce yourself or just listen in if you would like. You're, in particular, welcome to join our meetings that we do for hyperscale. We have IRC meetings every 2 weeks, and we have a monthly video meeting that's more of a social gathering so that people can see each other face to face. Also, there are a lot of SIGs, not just hyperscale. So if any of this work sounds interesting, you should browse the list and see if there's anything there that strikes your fancy that you maybe want to contribute to and help. And then, of course, you can and should file bugs if you find them. You can maintain packages in Apple or in Fedora. Fedora has excellent documentation on how to get started and contribute. You can start from that Fedora Magazine article, which I think is a great entry point. I, myself and my colleagues have given several talks over the years on this subject and related. We've tried tracking them on the link at the end of the slide. So if any of these sound interesting, or if you wanted more details on specific things like systemd, I'd encourage you to check that out. Finally, if any of you happens to be in Boston in 2 weeks, we will be there. There are going to be several events at Boston University between August 16th and 20th. There is a hyperscale meetup on August 16th, where a number of us will be in a conference room somewhere talking about hyperscale. seeing if we can drive things forward and probably getting some work done. On the next day, there is a CentOS dojo. If you're involved in the CentOS community, dojos are smaller scale conferences where folks present the work they've been doing. The past few dojos have all been online because COVID, obviously. But this one is in person, so it's a great opportunity to meet people face to face and see them again after a few years. And then there is DevConf, which is a great conference that is sponsored by Red Hat. That will also have a lot of talks relevant to the Fedora and CentOS and Red Hat ecosystem. That's also at Boston University. That link is a link, and the QR code is a link to the latest CentOS newsletter that has references to all of these things where you can find where you can sign up. All of these events are free, to be clear. There's nothing to pay. You just have to get yourself to Boston somehow. That's all I have. I will be happy to take any questions if there's any time left.
What does ELN mean?
Enterprise Linux Next. It is not a good shorthand. Don't Google that.
Or El Nino.
Yeah, or that. Oh, you're right. No, that's actually probably what it meant originally.
There's a whole bunch of puns related to this.
Yeah.
Like the weather thing.
Yeah. In your use of ButterFS in production, have you found it to be pretty stable or able to handle corruption?
Yeah. For the general answer is yes. I would say if you are running ButterFS in production, I would recommend running a recent kernel. A lot of the time when you see folks reporting having a really bad experience with ButterFS online, they will be running a kernel that's, say, older than 5.2. There were a lot of improvements made to ButterFS in the more recent years. So I would say if you're running a relatively recent kernel, you should have a good experience. We run ButterFS everywhere in the fleet. We don't really see any, I don't think we've seen corruption issues in a long time, to be honest. Yeah, at most we will see perf-related stuff that can come up occasionally, and there's of course ongoing work to optimize specific parts of the file system. The other thing I would say around ButterFS, there are features of ButterFS that are more suitable for production and features that are less suitable for productions. I would not run the RAID 5.6 code as it is in the current state in production, but it also puts up a gigantic scary warning right now if you try to use it. So.
And it's disabled in the stuff.
Yes, and we disable it purposefully in hyperscale because we don't want people to use it. There is active work to fix that for what it's worth. So I expect a year from now that should also be sorted out.
You may also find yourself surprised to discover that your disk drives are not as good as you think they are.
Yes, that is a very good point that Neil is making. One thing that is important to realize that ButterFS does, because it does effectively continuous checksumming of all the data, it is able to detect issues much earlier than other file systems. So if you're running something like Extended 4 and you happen to have silent corruption because your disk drive controller is randomly flipping bits, you may not notice until you actually read the file and see garbage. With ButterFS, you will start seeing DMES spew that will tell you that your data is going away, and that's a good signal to put your hard drive in the trash and restore from backups. But if your hardware is on the fence, sometimes you see these on consumer laptops where the memory isn't fantastic and they don't use ECC, so they might have bit flips every once in a while. So they're mostly fine, and you don't really notice if you're using them for just browsing in Firefox or something. But with ButterFS, you will see it immediately in DMES, and it will complain loudly because your data isn't safe. Sure. I will put the slides online. I haven't figured out how to upload them yet, but I definitely will. I also generally put these on SlideShare, so you should be able to find them fairly easily. If you can't find them, feel free to email me. No, but I figured I can just Google my name, and it should be easy to find.
Sure.
Yeah. The Cavalca at a bunch of different domains usually works. Anything else? Yes.
This is more like open source stuff, but how does the Fedora community make sure that any contribution doesn't make a project deviate from their original purpose?
What?
What do you mean?
So let's say, I'm confused. Let's say that somebody, you want to extend one of its core libraries of Fedora, right?
Mm-hmm.
But for some reason, that guy, that feature that he wants to add, it's something with it, like let's say DNS, right? It has to do with network component, but maybe he's adding something to the library to one specific file that's.
Oh, I see what you're talking about. So the question is about how do you ensure in a distribution like Fedora that builds everything from the same set of packages, that if upstream has a preference for a specific version of a library or a subcomponent, how do you deal with that delta? Did I get this right? Okay. So the reality is that you kind of don't. Like the distribution is built all from the same set of packages. In the vast majority of cases, this is fine. It might mean that if upstream has a preference for a specific version of a library, they won't get that. They usually will get a more up-to-date one. This is generally fine. In the situation where it isn't fine and they really need to have a specific version, there are ways to package multiple versions of a library and make it dependent. The downside of doing that, though, is that these things have security issues oftentimes. So if I pin you to, like, I don't know, an old version of like the bind libraries or something, and then there's a CV for those, we're kind of screwed. So usually we need a really good reason for it. What tends to happen more often is that some projects will fork and modify internally other components and like bundle them together in a way that you can't really reuse the other one. They effectively fork the library for themselves. In that case, yeah, you just end up bundling and dealing with it, and hopefully it doesn't have too many security issues. This is a distribution problem in general. This isn't a Fedora specific thing. It's an issue for pretty much all distributions that use a single stream of versions altogether. Did I answer your question? Anything else? Going once, going twice. Thank you very much, folks.
I'm not going to ask structures. That's terrible.
All right, how do I turn this off?
Okay, can you hear me? Ooh. Okay. I don't know how this will. There we go. Should be right. Okay, but the problem is the support part. Okay.
Do you want to turn the mic off while I'm fiddling with it?
Sure. This is it. All right. Good. Okay. Thanks. I'll start since it's 1:32. All right. Thanks for coming for my talk. This is the monolithic story, how the circular economy enables open hardware. And so, let's hope. A little bit about me. No, let's not talk about me. Let's go and move on instead. So let me ask a question. What is a circular economy? Does anybody know what that is? Right, Joyce.
Attempt to like reuse hardware and other materials that go back into the economy rather than digging up new materials out of the earth.
Exactly, right. And you gave some good examples of the economy, circular economy. But yes, ultimately, as you would know since you're part of Endless, circular economy is about sustainability. It's about carbon footprints. It's also about cats. Okay, no, maybe it's not about cats. Sorry, cat. there's no, nothing like that. So, but here are some good examples of circular economy. So if you're the one everybody knows about is plastic bottles turning into something else. Whether there's some actually nice shoes, women's shoes that if you turn from there, that's become really popular as a brand. Shopping at thrift stores, secondhand stores, all those kinds of things are another great example of a circular economy. And finally, things that take raw materials that you find in the trash or something else and turn into something else. So, wood or a piece of driftwood lying on the floor, or, well, not on the floor, but on a sand beach or something like that is another great thing. I saw a YouTube video of some guy who found something in these huge iron, like from a shipyard or something, right? And he turned it into a sword, a Japanese sword. So those are like really wonderful examples of how you could take something, turn it into something valuable, and resell it. But to put a more formal definition, it's really just taking raw materials and turning it into something else, right? As I just said before. And to kind of put it in scope, you don't want this. You don't want a place where you dump all your stuff. You really want to do this, where you're doing reuse. And that's the most important part of the circular economy, is to, as you were saying, is to take something and put it back and reuse them as much as possible, because we don't want waste. Every time we throw something away, we're actually paying a carbon cost. So how does that relate to data centers? Circular economy and data centers. Well, there's not much going on circular economy and data centers. There's actually only one primary company that is really looking at circular economy and the data center. So we actually have a lot of work to do in this space, because it is there's no players. There's really only one, and we got work to do. And you know, we got to have angry cat feeling here, right? We've got stuff to do, and I think it's important. One of the things why I wanted to give this talk is to give that feeling of we have a duty to reuse as much as possible, and that there's actually tangible benefits of using the circular economy, which you'll find later in this talk. And why it's imperative is, I think if you wander around in the talks in this conference, you can understand that we have a hunger for data. We want to collect data. We want we have Facebook, we have social media, we have cloud, we have on-prem clouds, we have off-prem clouds. We need and we hunger for data. We're really interested, and because of that, the demand for compute is high. So we're buying hyperscale class machines. We're having exponential growth in the data centers around the world. We can't get enough. Now, what do you think happens after that 4-year depreciation? They go into a dumpster or their landfill or something. What an incredible amount of waste, right? And so if you apply the circular economy to the data center, we're actually promoting reuse as much as possible instead of putting them in a landfill. And that reuse actually promotes low carbon footprint, because we are actually deferring the carbon cost of manufacturing for all of them. So it's important. And if we don't, we want to defer as much of that as possible and make them useful for many lifetimes. Lowering that carbon means that it's great for our planet. We are addressing climate change because we're not manufacturing so much with that reuse. So it's good for humans, it's good for our nature and ecosystems, it's great for our planet. So I told you there was one player involved, and that's IT Renew. And this chart here kind of shows how that circular economy works. So IT Renew, what goes on there is they take supply, and that's Meta or Facebook, Dropbox, Google. All those things get sent to IT Renew, which decomposes those components, deposits them into their individual components. Once that happens, they get recertified. Sometimes they get sold back to the hyperscalers, but then there's this other interesting idea that came about, and that why can't we build servers ourselves instead of just selling it on the open market? And that's what was the cool idea about that. right? Because you can take those servers, recertify them, and then sell them to second-tier markets. Now, what are those second-tier markets? They're gaming, they're banks, they're, well, I said financial institutions, whatever it is, right? Universities, there's so many governments, there's so many places, and we're giving these servers a second life, and possibly even a third life going on. So, and these servers are not some low-tier 20-year-old servers that one would think. They're the highest you can get, the best you can get at time 6 years ago. And now we can reuse them and send them out. The other great thing about it is uninterruptible supply of IT components. You know, this pandemic has taught us that supply chains are fragile, extremely fragile. And this is what is driving the cost of everything in the past 2 years. Now imagine having a supply chain that's local. So ITRenew has localized warehouses across different continents. So you're not shipping them overseas or anything. They're actually in Europe, they're actually in the US, they're in various other places. And so we're taking almost over 21,000 servers a month that gets incorporated and then and turn them into components. So that's pretty substantial supply to be used, right? And think of the other so you're getting them all, they're all localized. And I think that's a pretty powerful argument when, especially if you're a government, right? If you're getting it from your local thing, then you're not worried about any security issues because you're getting them locally. Okay, so I talked a little bit about the hardware supply. What else is interesting about it? So I think if you're going to rebuild and recertify servers, I think we have to change the paradigm in how we do that. Sure, we have existing standards, especially for racks or things like that, but we could do more. We could be more open. We could be doing more collaboration in this space. In fact, that collaboration is already happening. So we have standards, we need specifications, and most of all, we need a community. And we might need cats. Or maybe not. Maybe we don't need cats. What we need, though, and roll the drums, is the Open Compute Project. The Open Compute Project was actually started by Facebook. And it's a foundation dedicated to working together and building an open compute model across many parts. So in this way, the circular economy is joining a community of people who already are interested in an open specified data center. And I don't know how well you can see all these logos, but these are all people who are cooperating together. You have the hardware manufacturers, the ODMs, you have Facebook, you have the hyperscalers involved. And you have folks that are interested in networking, open networking. There is a wide variety of people working together in each of these parts. So it's a pretty amazing place. I've spent some time, I've spent 2 years working with the Open Compute Project, and there's a lot of great things happening there. So here's the kind of benefits that OCP provides, right? You see things like high flexibility. You know, one of the things we did at ITRenew was different form factors, right? We're actually all collaboratively designing together with different form factors that you can address. Let me give you a couple examples. Edge computing, right? you don't need huge servers, you actually need small ones. And there was this notion that you can put a data center anywhere, especially if there are small form factors. You can put them in underserved communities. You can use the output of those servers to heat homes. In fact, there's all these great things that we're talking about, like how do you reuse even the data center parts, the cooling, the exhaust. These are the kind of wonderful things that are happening in this data center space that most people don't know. The collaboration in this project is extremely impactful. We had one, I think there was one where we were taking the output of the data center and powering greenhouses. And so they were making marijuana. But anyway, they're a medical thing. But they went there and they used that, and it's like the output of this gave some kind of organic matter that it can be used, right? The same thing could be used for cooling or heating homes during the winter. So these are the kind of problems we're trying to tackle. In additional, we're looking at how do we improve cooling. So a lot of things we're doing in the open computer is how do we make dense racks, right? So once you're doing dense racks, then you're like, okay, how do we deal with the cooling issues? How do we do the heating issues? So all of these are collaboratively done here that we're all a part of, that we can rely on. So the engineering is not all done on one company, but it's geared across, it's spread across all of them. Now you're wondering, what makes all these companies work together like that, right? When there are competitors. It's because everybody is solving the same problem by themselves. What is the point of that? We're wasting engineering space, but we can't collaborate on the common problems together, and then our competitors can distinguish themselves on top of that bedrock, right? And that's why they work together, and that's why this project is so important, is precisely for that kind of thing. Okay, so let's talk about the monolake story, right? I don't know if this thing is going to play. I've been playing around, I'm sorry. Okay, so what is the monolake? It's a platform that was designed by Facebook and contributed to the Open Compute project in 2015. And it was designed for Facebook data centers for hyperscale workloads, right? And it's a pretty interesting platform. I will add, this is not the only platform Facebook has contributed. They've contributed several, at least 4 or 5, and the latest one is Delta Lake, which was just recently contributed November of last year. So what is it? So the monolake is actually a combination, right? There's something called Yosemite V1, and this is what you're seeing here. This is the enclosure, the design of the enclosure. There are 4 slots in the chassis, and each of those 4 slots contains system on a chip. And so each of them is 4 of them, right? And each of them is a Xeon D1500 series processor with up to 32 cores. And it comes with a BMC chip. The BMC chip actually talks to all 4 processors at the same time. And then each one of them has 128 gigs of memory. So with all of this, you're looking at one card, about 128 cores, and 512 gigabytes of memory. That's a lot of firepower, and that's just one. And you can see a picture of that, what it looks like there. So imagine what 48 of them are. And 48 in a full rack, that's 192 discrete CPUs, not including the cores, right? And I think, I don't know about you all, but I'm pretty excited about what you can do with that. I mean, for a hyperscaler, sorry, I'm going to just do it this way. For a hyperscaler, this is nothing. But if you're a second-tier market, you should be drooling right now because this is an incredible amount that you can get on one floor tile. And the best part is it's designed to be open from the beginning. This is not going to work out. Give me 1 second. Okay. That's what's great to be about an engineer. Thank you. Thank you. Thank you very much. I am an engineer, everybody. Okay. So anyway, going back to my point, it is designed to be open from the very beginning. And when this collaboration was actually between Facebook and Intel, and of course many others, and they wanted to build a hyperscaler platform. And the collaboration is great because I think, like for Intel is sort of the gatekeeper here in terms of a lot of the firmware and things like that. So, you know, to have Intel come to the table and work together on doing this kind of thing, it's sort of pretty awesome. Imagine all these, how much we struggled for in the past trying to find open hardware. Of course, Raspberry Pi is a great example of an amazing thing, but you know, when you compare it to a monolake, it's pretty small in terms of as a computational unit. And it's great for a certain class to solve certain class of problems. But if you're trying to build large, wide, scalable solutions, then this is a great thing. And in the link here, you can see if you're interested in seeing what the specifications are for the monolake. I have it here, and I'm happy to supply that to you. It's also available on their website. Okay, sorry. Now, where are we? But so far, I've told you nothing, right? What is the story? I think I wish there was a way. So I'm a poor engineer now. There is a mic, but can you turn it on? Here we go. Does it work now? Hello. Okay, we're back. Thank you. Okay, all right, we're back. And now a much simpler device rather than. Anyway, I'm not being specific. So the reason this slide is here is there is a story from before. We're just breaking it down because a lot of times it's about context. How do you know what's great? So if I didn't explain what the circular economy was, then you wouldn't know the context of the story or why this is important or anything else. If I didn't talk about the Open Compute project, you couldn't really understand how the work required to put this together. So, moving on. And I need my glasses because I can't see my slides. All right, so we got the specifications. We've got the hardware. We're ready to put some servers down. What's the problem? Well, okay. Remember when I said this hardware is old? It's 4 to 5 years old already. So what happens to old hardware?
Can't
I'm sorry? Yeah. The other thing is, nobody wants to support it. Nobody cares. The lights have been turned off. They moved on to the new thing. The salespeople are like, oh, forget about that one. We got this really brand new one. You don't need 12 cores. Here's one for 34 cores. You don't need all that. But we're just a dental office. No. So the problem is that nobody wants to do support these new things, right? And that gets problematic. So if you're trying to sell somebody a server and it's running old stuff, and they ask you, well, what's the software updates? There's no software updates. What about security? Oh, there's not that much security updates. So that's a big drawback. And so if your BIOS is old, everything is old, so how do you fix that? How do you fix making these old hardware relevant going forward? You move to an open source tool chain. So that's the best thing, right? What's so great about the open source tool chain? It's community supported, and we can support it as long as somebody's interested in using those platforms. You can create an entire ecosystem just supporting that. And that's what's great. Once you get that going, we can support these servers in perpetuity. Now, some of the ODMs might not be happy because they want to sell you new hardware, but there are some who are always going to be cash strapped. Government, schools, all of them, they're like, we can't. And a lot of times there's an upper bound. I'm never going to need more than this, right? And if you're doing 21,000 servers, there is a lot out there. If something's broken, you can just replace them, and it's pretty cheap. And they're a fraction of the price. So I think that's a great part. And circularity, we need that openness, right? Otherwise, this model doesn't work. If we can't rely on open source and open specifications, this model does not really work to sell servers. And so we have to, so a lot of this is laying that groundwork to build sustainable platforms. Okay, so this part is really the work required to replace a tool chain. Looks kind of simple. Oh yeah, we'll just put core boot on there. It boots off Linux boot, and then, victory. It's not that simple. In fact, the engineering required to do this is extensive. So it is not hard, and I think others, even for the newer platforms, there's so many pieces that has to align to make things work. It's actually easier for later models, but for models like the Mono Lake or the Leopard or some of these other recipes, it is a pretty heavy lift to get them up to modern standards. But that's what I have to do to rely on it. So to enable core boot, you need an FSP, which is the firmware support package that comes from Intel. And it's the binary, we cannot avoid binary blobs. If you're using the x86 platform, and I think even ARM to some extent, there is a binary blob in there somewhere. And what is this binary blob? It's pretty much expresses the Intel platform and all its capabilities. The second thing is there's a BMC chip on there. Now there's a project called OpenBMC. And there's actually 2 OpenBMC projects. And one is run by Facebook, the other one by the Linux Foundation. And then finally, the kernel needs to recognize the hardware and actually boot. So that's the next stage of engineering to get this forward. So a lot of engineering, right? So we actually had to hire a contractor and CISPRO Consulting to help us with this endeavor. And the great thing about them is they actually have a license to hack the FSP, which is few and far between. I don't think Intel is that forthright in giving license out to hack that. I think a lot of it is plausible deniability. If you hack it, they don't want to support anything that's hacked. And the other thing here is that where the FSP is. So the monolith is actually FSP 1.0, and that's is only supported by an older version of the core boot So that's another bit of engineering. So 1.5 years go by of working. And so we solved the core boot plus FSP problem, and it was hard. A lot of tacos were involved. We forward ported the changes to the current core boot branch. So we took all the stuff that was in the older core boot branch, and then we forward ported them into the current one and upstreamed all that. And it was hard. It involved a lot of tacos and ice cream and martinis. Then finally, the kernel changes to the Yocto kernel, which I think is 4.0. It's the funniest thing about upstreaming changes to the kernel. A lot of companies do not want to directly contribute to the kernel. They rather do the Yocto kernel, because to get anything into the kernel, the mainstream kernel requires at least 1.5 years to get in there, because the first time you kind of contribute, you know you're going to screw up. Then the second time, there's going to be another set of things. The third time, finally you're getting around to shipping it, and then at last it goes in. Instead, you can go to the Yocto kernel, which has much more relaxed ways to get in there. So a lot of times we end up using the Yocto kernel for embedded and various other things. And also more tacos. So what was the end result of all that engineering? So the FSP now supports 8 cores. I'm sorry, it initially supported 8 cores and 16 threads. And then we doubled the resources and made them 16 cores and 32 threads. And so we made the FSP a lot more useful. So that's a pretty good tangible benefit. It still needs more work, but that's one improvement. So this is something the circular economy has helped enabled. We had to go and get Linux Boot to be able to support features that customers actually want. Otherwise, it's just a toy. So if you don't have iPixie, then that's not really useful on a hyperscale platform if you can't easily put operating systems on it. Let's see, what else do we got here? And then we had to support all the file systems on the storage. So if you can't get Extension 3 or 4 or Btrfs, not very useful, because then you can't boot an OS on it. And then finally, we did actually manage to get booted to Ubuntu, and so that whole thing took about 1.5 years to get into a shape. And this is our family dog. He's celebrating. He's happy. We're all happy. But I can't underscore how much work this was. And it's not just the engineering work. It really required looking through the documentation on the platform, going through the FSP documentation that Intel provides, understanding all the data structures inside there. How do you expose, what data structures to expose to enable this feature X and feature Y, schematics, debugging tools, all the flashing software. Sometimes you screw up the thing and turn it into a brick, and then you got to figure out how to get it back off again. Then there's the kernel code. You got to look at the commit history. So everything, there's an incredible amount of work, and it's you got to keep going from one step after another. And so in the end, we did get something that we submitted to the Open System Firmware team at OCP. And so it was accepted into their repository in January 2022. And so we have a working system of sorts, but it's only one, chapter one, because there's still a lot of work to do. And so what's next? Well, it doesn't work with all distros. You got Ubuntu working. It doesn't work with free, like the BSDs. It doesn't work with Windows. So, you know, if you're following the process core boot, UEFI, and Windows, maybe you don't care about Windows so much. But we do want to get all the other distros working, like Red Rel and all that stuff. So we're going to need a lot of help from the community going forward. But there's a glitch. So IT Renew was actually acquired by another company, and the parent company was not really geared to selling products like we were doing, and they were more of a services company. So unfortunately, they had to dissolve the Sesame team that was doing the work. And but I think one of the great things, and this is where the resilience of having open source and open specifications, is that first we proved that this business model actually works. We have generated millions of dollars in profits in actually selling these hardware and doing it. So this is a concept that can work, and we have proven that it works. And so that's something we're really proud of. So a good idea never dies. And because these are assets that are freely under free licenses, we took everything, we extracted everything we did internally, put them on a GitHub, we put it on Notion.io. Nothing is lost. No, this endeavor continues to stay in the open, and that's great because even the customers who may have purchased our thing, they have access to all the information they need. So they can still go on self-support if they wanted to, or they can hire the former team that was working on it. In fact, my boss is doing another startup precisely. The way Sesame was created was actually as a client to IT Renew. So IT Renew's core business continues, but we were tapping into their supply chain to do our thing. So the only difference between what this new company does and what Sesame was doing was Sesame was part of the company. But there's nothing that says that you can't keep doing that just without that formality. So I think we're still in the game. We're still going to continue working on things like the Mono Lake and Yosemite V2 and all these other things. It just may take a little bit of time before we get our investors back in shape and being able to get back and do things. And besides, we have a planet to save. You know, we got carbon to save. We got to stop moving these things into a landfill. So you know, it's imperative that we do that. And there's so many other projects that this can key off, right? Again, going back to those form factors, going into underserved communities, building data centers that can be functionally part of communities, because one of the interesting challenges, I'm sorry, I'm going on a tangent, is that, like, if you're trying to help an underserved community, a lot of times if you're doing investments, you might trigger something where people are pushed out, right? And instead of helping them, they end up you're starting kicking them out, right? It's but a data center doesn't do that. It just stays there and it's inert. It doesn't attract things, right? So that's the best part. So anyway, going back to the monolake after my thing. We actually are setting up, the OCP is setting up a lab that you'll be able to play with them. So if you wanted to have an access to a monolake, we are actually contributing monolakes, leopards, wedge 100s, which is another thing that comes from Facebook for open networking. There's a whole slew of things, Delta Lakes. So, you know, what's exciting is that it's happening. Open infrastructure is happening. And I think that is exciting to me because we can now start leveraging, building things more open. And if we start combining the open source ports of hardware and with the open source, we're really building a whole new family or direction of openness with specifications. A lot of time we talk about our values in open source from a software perspective, but we never think about the hardware, right? A lot of times I put so much talks at the KubeCon, say, okay, you know, you're using killing all this carbon stuff, and every time I say, well, it's Kubernetes, we don't care about the hardware. But you do have to care about the hardware because the hardware is generating carbon. And you can't sit there with your, whether it's Google Cloud or whatever it is, you should actually think about your values and think, are we using that hardware properly? Instead of the latest, can we get a circular economy? So, and now we're actually getting circular economy that could meet people's needs, at least even from a hyperscaler perspective. So that's something I'm really passionate about. So I've come to the end of my talk. I have decided to show you all the pictures of my cats because, you did get one dog, but I didn't get a chance to get a dog in there ahead of times. But thank you for spending 45 minutes with me. Or the talk is 1 hour, but I hope you enjoyed listening and maybe hopefully you feel impassioned to help out in open hardware. And this is me. And if you're interested in that startup, or if you want to know more about the open hardware, I'm more than happy to connect, provide information, anything else. I will say you need to speak up. I have some hearing issues, so if I don't hear you, please don't be offended or make you repeat. So, thank you. Any questions? You, sir.
I have two questions.
Okay.
You mentioned your GitHub repo where all of these is. What's the repo?
One more time?
You mentioned you had a GitHub repo?
Yes, yes. There's a GitHub repo. There's one that's part of the Open Compute project, but we have another one that's also part of Sesame Engineering that's out there. Yeah. So there's two of them. That one has other documentation, things like that. There's also a Notion.io but that's not quite public yet. But our entire knowledge base is on that one. So yeah.
The other question I had was you mentioned you were working on distribution enablement, and earlier you mentioned you were focusing on using the Yocto kernel. Without knowing anything about what you're doing, my hunch is that if you get your changes upstream into the actual Linux kernel, you will have a much better luck getting distro enablement for other distributions without having to make anything yourself.
Yeah, I think the problem is that I'm restricted to whatever everybody else is using, and I think that's why. Like I think originally where it was coming from Facebook was using that. That's my recollection, but don't hold me to it. But yes, if we could, I agree with you there. Yeah. Yes.
You had mentioned in your talk that you actually have this hardware at home that you play with, right?
Yes, I do.
How would others get a hold of it if they wanted to kind of like, play with it, see what it could do, or maybe?
So at the moment, we bought up, so the one I have, let me see if I can show you what it looks like. I have it's called a Discovery. This hardware, this form factor that you can fit under your desk, it actually will fit 4 one-use systems. So I actually have 2 leopards and 3 leopards and 1 monolith in one thing sitting there. They're really, really noisy. So I don't actually put the monolith in because I can't hear anything. But the leopards are great. So I could show you afterwards. I don't know if anybody else wants to, but to acquire them, my boss purchased all the inventory that he could get his hands on prior to leaving. So I can connect you if you're interested in purchasing and things like that. We were selling them with leopards from around between 9K to 12K. So essentially, you're getting an entire data center in under your desk because it does everything. It's got a BMC chip. You can take it from remote. I can access my machine anywhere thanks to Tailwind VPN, which is amazing. I actually I just installed all of them and I can access all my machines wherever. It's fabulous. So I enjoy that. Yeah. Yes, Miss.
Sorry, did you say there was a startup? And what's the name of the startup?
I don't think he's come up with a name just yet. He's still busy talking to investors, but like I said, I can connect you to him if you're interested in that.
Thanks. My name's Amy. I'll send you an email.
Okay, great.
So, thank you for the presentation. I completely agree with the sentiment that you have. One worry that I have, I'm a software guy, okay? So maybe
Yeah.
I'm wrong on those matters. But looking at this, especially dealing with older Intel processors, you don't get microcode updates, you don't get patches to the management
That's right.
engine, which is a massive security liability, even when they maintain it, and
Mhm.
so no version 0. Anyway, so of course all of this depends on Intel, on delivering things like that, I suppose. How do you want to address that? Because ultimately, even if you design the best server design, you are at the mercy of those potential vulnerabilities in whatever CPU you have in there. So what's the plan there to make them move to a more open stance?
So I think this is the sort of thing that has to go through the Open Compute project to work with Intel rather than like one company cannot do it, like but it works better if a community comes in and works together with somebody like Intel or whatever it is, right, to do that. So I don't have any answers there. However, as of 3.5 weeks ago, I am an Intel employee, which means that I have some ability to go internally and figure out if there are solutions that we could do. But ultimately, it's up to the business groups that involved to make decisions. So.
For what it's worth, I'm pretty sure you can apply microcode updates for previous generations. You just won't have them baked into the firmware, but you can apply them at runtime. And I forgot how back they go, but it definitely support a number of previous generations. And if something nasty comes out, they usually fix it.
And that's a possible approach. The other potential problem is when the next spec or hard bleed or whatever hits.
Oh yeah, absolutely.
And then you're stuck with things that you cannot fully secure going forward. So this could, of course, be obstacle to adoption of this.
Yeah, you won't last forever, for sure. And Intel, as far as I know, doesn't publish change changelogs for these things, or at least they don't publicly publish, I should say, changelogs for these things.
Yeah.
So that's another issue where you don't really know what you're getting.
You can also disable that and then turn that on.
Not completely, that's the problem. It will always stay lurking around and could be reactivated by an attacker.
Yeah, but this is also, it's not just DME, but also just if there's a flaw in the silicon design, sometimes they can fix it in microcode, but sometimes it's just like, yeah, you can mitigate, but you have to turn off all the caches and then the machine kind of sucks.
Any other questions? All right, fantastic. Thanks you all for coming. And if anybody's interested, in seeing what my machine looks like, I'm more than happy to show you some photos, especially the ones we've designed, the enclosure and things like that. So there's some YouTube ones too that we did that you can look at.
And there's some Open Compute project materials here if you want to take a look.
Oh yeah,
Yes,
if you want to compute swag, there's plenty.
Yes, there's some swag there. Thanks to Meta slash how do you turn this on?
Good job, this is cool
Thank
stuff.
you, appreciate it.
Yeah.
You know, it's always, I remember some of the folks on Facebook would feel very frustrated. One of the problems with OCP is they spend too much time with their members. They don't go out and advertise. Like, how many OCP?
Yeah.
Like, as far as I know, the only one out here in the community actually talking about it.
It's tricky. It's also that for microphones off, right?
Yeah,
Yeah, no, I
that.
just didn't find out.
Hot mic, wait.
Yeah, turn this off.